This is CPM Calculus Chapter 2, number 28. Okay, so I highlighted a few key words in this problem. We want to set up an equation using the trapezoid that is going to approximate the area under the function f of x equals to cosine of x on negative pi over 2 pi over 2. So one thing to note is we're going to approximate using the trapezoid rule. We need 6 trapezoids of equal height. Okay, and then part 2 of the question is how to use the fact that cosine is even to save yourself some work. So let's start off by looking at the cosine function. We know that it has amplitude 1, starts off at x equals to 0 at height 1, goes down to negative 1 at x equals to pi, goes back up to positive 1 at x equals to 2 pi. And it cycles that same little sinusoid starting at 1, negative 1 to 1, over and over every 2 pi. And it repeats and repeats and repeats. So that's what we know about cosine. Now let's just look at the specific area that we want to find is underneath cosine between negative pi over 2 and pi over 2. So if we look just closely at just this region, we are going to look at just from negative pi over 2, we want the area under the curve for this whole region. And specifically, we need 6 trapezoids. So I want to break this from negative pi over 2 to pi over 2 into 6 regions, starting at negative pi over 2 and ending at pi over 2. And so we have 3 here on the left, 3 here on the right side. And just looking at how to do that is you can just do it algebraically. You could either divide the whole thing by 6 or just take the right half. From 0 to pi over 2, we want to divide it by 3 because we want 3 separate regions. So dividing by 3 is the same as multiplying by 1/3, so that's pi over 6. So we know each width is going to be pi over 6. So 0 plus pi over 6, pi over 6. Pi over 6 plus pi over 6 is 2 pi over 6, which is pi over 3. 2 pi over 6 plus pi over 6 is 3 pi over 6, or pi over 2. So it looks good. And we do the same thing on the left. So we have those regions defined. And then we are going to now approximate. Approximate is one important word because if you look at it, there is some area between the curve and our approximate trapezoids that is not accounted for. So just keep that in mind as we're approximating. Let me remove this bottom layer so we have some more space to work. But let's start off by looking at our function. Okay, so our function again is f of x is cosine of x, straight from our definition in the question. So our area of f, so between negative pi over 2 and pi over 2, between our function and the x-axis, right? We're given both those. Is approximately, so make sure to use the approximate symbols when we're approximating the area, because it's not exactly equal to, but is equal to, and then all the areas underneath, all these trapezoid areas underneath the curve. Remember, the area of a trapezoid is 1/2 base plus base times h. So when we plug that in, we get approximately equal to, then we have 1/2 from straight from the area for trapezoid formula, the function at negative pi over 2 right here, plus the function at negative pi over 6 right here. So we're getting these two heights times the height of the trapezoid, which is from 0 to pi over 6. Each width here, we already talked about it earlier, is pi over 6. So we multiply that pi over 6 in, and we just want to shade this in here and show that this right here, this trapezoid, is equal to this in algebraic terms. So we do that again for each trapezoid, just 1/2 base plus base times our height, and we do that for every one of the trapezoids. And this again gives us an approximate area. So I want to make sure to use that symbol because it's approximate. We can simplify it if we notice that each one of these has a 1/2. So 1/2 here. Each term has a 1/2, 1/2, 1/2, 1/2, 1/2, and then also a pi over 6. So this term has a pi over 6. This one pi over 6. This one pi over 6. Pi over 6. Pi over 6, and pi over 6. So we could factor those out, and basically what we're left with is f of negative pi over 2, straight from here, plus f of negative pi over 6, plus f of negative pi over 6. So we have two of those, we could just say 2, plus 2f of negative pi over 3, and so on. Okay, so let's make sure I didn't do it right at first, but let's make sure to use the approximate symbols because we're, again, approximating the area. And remember, that's because we have this area right here, 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 and here that is not being accounted for. So our approximate area is that. Okay, let's box our answer just like I showed. And the second part of the question is like asking, like, just how can we save work given the fact that cosine is even? So if you look the left side, if this is the y-axis right here, the left side and the right side have the same area if you're just strictly looking at the left and right. And that's because it's an even function. We can reflect across the y-axis. So we can say that the area from negative pi over 2 to pi over 2 is the same as 2 times the area from negative pi over 2 to 0. Or we can say it's equal to 2 times, again, the area from 0 to pi over 2. So we could say it's 2 times the left area or 2 times the right area because our function f is even, cosine of x. So this answers like both the first question and also like how to save ourselves some work. We could just cut this down. We would reduce a lot of these terms and just multiply by 2 at the end. So this is CPM Calculus Chapter 2, number 28, and we approximated the area under the curve, and we looked at approximating using, remember, approximate symbols, and then how to save ourselves some work in the future. We learned how to do that.